No, we're live. We're up.
Great. Sorry about the delay, everyone. Just had a couple technical difficulties, but welcome to this week's AM Friday. Today we're going to be breaking down a cost analysis of the Markforged metal 3D printing process compared to the Dmls laser-based metal printing process.
Yep. So just talking about Dmls, which is the standard kind of in additive manufacturing now, the longest tenured technology, and then comparing it to ours. We're going to go a little bit deeper in detail about the cost of actually operating both a Dmls type printer and our printer. We're going to first kind of talk about just general costs, and then we're going to talk specifically into a Dmls machine and then to the Markforged Metal X system, which we covered last week. So first a couple updates from Markforged. Nick, you want to take it off?
Yeah, so we've released a new nylon material. So if you are a more senior customer of Markforged, you may be printing in nylon. And so we basically updated that material so it's got better mechanical properties. It's not going to replace Onyx, it's just another thermoplastic option to print with your composite parts. And so that is available now.
Yep. So if you already print with nylon, what we call tough nylon, you'll have the option to print with what we call nylon W now. You'll notice it's white W for white. It's white as opposed to clear. As Nick said, pretty similar mechanical properties, a little bit better, a little more reliable. And then the biggest difference is that the machines can print with both this nylon white and Onyx. They can without conditioning, without needing it. Previously, you either had a nylon printer or an Onyx printer. So if you have a Mark II, you can print with nylon white now, and you can print with nylon white and then print with Onyx, and you'll be fine. And if you already still use your nylon printer, you can continue using that for some period of time, and then you can switch to nylon white. As we said, pretty similar mechanical properties, should be if slightly superior and a little bit better reliability, and also opens up the option to do it with both Onyx and that. So just trying to keep kind of increase our plastic throughput for every given machine. Not a new material, as Nick said, but just a general upgrade.
Yep. And if you're new, as usual, we will be answering questions throughout the video. So you can put your questions into the live chat, and we'll answer them live here on the show. So just as we talk about stuff, if you have questions, feel free to throw it in there, and we'll answer it as we go through.
Yep. So, and just another thing, one more last thing before we get started. Last week we did a 55-minute or an hour talk, pretty deep in detail about how the metal system works and all the details of the system. This is less focused on that and more focused on the actual costs and that maintenance and that kind of stuff. So if you want to learn more about the process, I definitely recommend checking out that video. It's AM Friday, episode 11. Before or after you check this one out, this will still be informative for you, hopefully, and we're still happy to answer questions about the Metal X in this presentation. But just so you know, we do have a whole thing about that. And with that, I think we should kick it off and chat about the first thing, which is when you're talking about the cost of a 3D printer or a fabrication machine in general, what are the costs we actually take into account?
Yeah, and so when you're making an investment in a pretty expensive machine, as you do in a machine shop, there's really two types of expenses that go into it. There's that initial investment that you have to put up front, which is the actual cost of the machine and any sort of cost you have to put into the environment you're putting that machine into your machine shop. And then after that, you have the day-to-day operational costs. So how much it costs to actually own that machine and operate that machine.
Yep. And with the upfront costs, it's often a little bit more complex than it looks, because you'll have a company have a listed MSRP, basically their suggested price, and that's the cost generally. And then you generally will see it like a turnkey cost thing. A turnkey cost is something, another similar term, and that's usually the cost that's usually closer to the actual kind of cost it takes to get going. But with a lot of these more advanced fabrication machines, it's not just you have one machine, the machine stands alone and works. Specifically, we'll get into a lot more with DMLS. With the DMLS machine or an SLM machine, you need a bunch of different machines to ancillary or extra machines to make that basic DMLS machine works. The Metal X doesn't need as many other machines, or there's a couple things. It doesn't explicitly need anything extra, although there's a couple things that you can integrate to make the parts a little bit better.
Yeah, so when we talk about operational costs, so depending on how you're calculating the cost of running the machine, depreciation is one of those. That depends if you're taking into account the upfront costs or calculating it concerning the depreciation day to day. The materials you're using in your prints, the power that your machine is using up while you are running it, and then what you have to pay operators who are interfacing with the machine and the parts, and then any post-processing you have to do on the parts. So that's going to depend on your application, what sort of post-processing you have to do, whether you're going to be hardening the metal, whether you have to post-machine it, and stuff like that.
Yeah, and I think when we talk about plastic printers or even our Markforged composite printers, we tend to think about operational costs as pretty similar to just the material cost plus maybe a small maintenance cost. Generally with metal printing, it's a little bit more involved because the machines are higher energy. They're more like they need a little bit more maintenance. They need a little bit more operator expertise. To some degree, this is true with the Metal X relative to our plastic and composite machines. And then when you think about SLM and DMLS, it's like a whole different ballgame. So when they say it like takes an army, it definitely does to make some of these things work. And so when we talk about these costs, it's easy to just think the cost of printing a part is just the cost of the material. For this kind of exercise, we're going to talk about how that's not actually true for most kind of advanced industrial printers, and what are the actual costs for something like the Metal X, which is kind of a more turnkey, easier to use solution in the metal space that still takes a little bit of extra work, versus DMLS, which is just a really amazing process that takes a ton of work to get good parts out of.
All right, so let's get started. So we're going to start talking about DMLS first. If you're unfamiliar with the process, it's a laser-based metal printing process. You have a bed of metal powder, you sinter it with a laser, layer by layer until you get your final metal part. Yep. That's a super quick overview. And if you want to learn about our process, you can watch our video last week where we featured it on episode 11 of AM Friday. So your startup investment with DMLS, this is the argument you hear against DMLS most commonly, is that the upfront cost is very expensive. And so we're going to get in later more about how the operational costs are actually a lot higher as well. But the upfront cost, depending on the machine, the quality of the machine you're buying, it can be anywhere between $500,000 to even $1.2 million. And so for this exercise, we're going to consider a more middle of the road DMLS machine, which is around 700 grand just for the actual printer itself.
Yeah, so small DMLS machines, there's like a couple of like kind of dental specialty ones, or ones that have really small build envelopes, like 4 inches by 4 inches by 4 inches, something in that range. Sometimes the machine cost is like as little as 250K, but most of there's a big cluster of machines if you look at the overall environment in DMLS that is like roughly a foot cubed is a build volume, and generally like about 500 to 800K. So we focused on that kind of area because if you're looking to get a machine in-house, that's likely the machine you're going to get.
Yeah, and so this is really just comparable build volumes between our printer and a DMLS of this price range. Yeah. And so you pay that upfront cost, so somewhere between $500,000, $750,000. And then what you have to do is upgrade your facility because you're dealing with metal powders. And if you have joined us on the show, you've heard us talk about metal powders before and how dealing with them is hazardous. And so you basically have to have a powder room, and you need to have air quality updates to the room. You need to be wearing personal protective equipment when you're interacting with the machine. You need to train personnel. And so you need an entire room dedicated to this metal 3D printer that's updated with a lot of high-tech sort of additions.
Yeah, and so the way you can think about it is the metal printers themselves, like a selective laser melting or DMLS machine, generally about a ton and a little bit more than a ton, so a couple thousand pounds. So it's pretty similar to say a big mill. So if you think about it this way, it's basically saying I'm going to take this big mill, but instead of just putting it on a shop floor, I'm going to have to put it in its own isolated room. And in addition to that thing, this big mill, which in this case, or this machine, which is in this case about like 7 feet wide by 8 feet tall by 4 feet deep, generally that's a pretty average size, you're going to need a bunch of other things that actually help that machine run, whether that be like coolant or powder storage or like a lifting tool to actually help load stuff. So the actual rooms are a bit bigger. So there's a really interesting National Institute of Science and Technology report where they set up a DMLS machine. And the room that they use to actually set up one of these very similar machines that we're talking about is about 18 by 15 feet. And this is just for one machine. So, and this room, as Nick says, has to be climate controlled. You have to have basically like an airlock so that you don't have metal powder you leave, and you have to have amenities for a bunch of other stuff. So the actual fabrication costs of the room runs into the hundreds of thousands of dollars, and then you have the install costs as well, where you have to bring this giant machine. And often when you're bringing in the giant machine, you're kind of closing it into the room as you build the room around it. So there's a whole ton of complexity around a machine that is as high energy as a DMLS machine is, and as like kind of uses powder.
Yeah, and so as an order of magnitude estimate, we can say it's about $250,000 that you're going to spend $250,000 on creating / updating a room to be able to fit your machine in a safe way. And so those are the two biggest upfront costs that come with it. There's a couple more that we're going to talk about, but already we're in about $1 million range. Daniel, want to talk about what else is involved in when making these parts?
So with DMLS is a really interesting process. So when you get back to what's required to actually make DMLS parts work, kind of the extra machines, you have to go back to the process, which is your the original innovation, which is just an amazing innovation, is they take metal powder and you shoot a laser at it and you melt it very selectively. And so that means that basically you're creating a metal part like layer by layer, but also kind of voxel by voxel. And so when you compare that to something like forging or a wrought part, those parts are basically melted. They come from molten metal, so all kind of molten metal all at once, and they solidify together. So there's not really internal stresses. There's kind of a reliable geometry. There's no cracking. With the metal, with SLM printing, because you're kind of going from metal powder to metal part, little by little, there's a lot of internal stresses that happen, and there's a lot of little cracking and some other things that happen, like warping and other stuff. The other interesting thing about DMLS or metal printing is because the way that it works is you have basically your print bed is a big piece of metal, and the part is literally welded to the metal print bed on the first layer. So that's how the part actually sticks down and doesn't warp. So with that, there's a bunch of machines required to kind of get moving. So the first one is you need some type of robust simulation software around metal printing to be able to predict what's going to happen in the high energy process. The second is you either need if you want to kind of do it more roughly, you need a really nice bandsaw, or more realistically, in the context of metal printing, you need basically what's called a wire EDM machine, not a super fancy 5-axis one, but like a 1-axis one. You probably need something to heat treat the metal parts with, because the parts need to be basically reheated to have the internal stresses relieved inside the system. And then you also need basically just general PPE for metal powder and metal powder maintenance stuff, whether that be like a special vacuum or a bunch of other things. The last thing that is not unique to metal printing, to SLM, it also can be beneficial with the Markforged system, is it's nice to have a CNC machine, because the parts that come out of an SLM machine often need to be finished in one way or another to reach that final part. So most people who are looking into these systems already have CNC machines in-house. It's worth noting that is something that's important there.
Yeah, so if you look at cost of all of this, wire EDM, kind of run-of-the-mill lower end one, you're gonna be seeing around $50K for that. And then plus metal powder vacuum and a heat treatment furnace is gonna run you another 10K or so. And then a CNC machine you probably have in your shop already if you're gonna be buying a metal printer, so that's not gonna be an additional cost. And so that's basically all of the upfront expenses of DMLS. So you're running somewhere in the range of $1 to $1.3 million in terms of how much cost you're putting directly up front before you even start making parts.
Yeah, and it's worth noting also that you can't just, buying the printer will not yield the parts. You can't really just get it. It's not like an optional thing. You really need a suite of products to make a metal printer like an SLM machine work well. There's a couple of questions I wanted to get to early on. So what's the optimum laser for DMLS versus atoms, for metals versus plastics? Not exactly sure what you're getting to there. The atom process, our process doesn't actually use a laser. And with a DMLS process, the laser comes with the machine. So if you can clarify that question, that'd be helpful. Someone asked what industries you think it'll be best for. The Metal X is like a manufacturing machine in terms of like what verticals. We've seen it in a number of verticals. I think the ones you listed are interesting ones as well, are good ones. We've seen maybe some stuff into the biomedical field, into just standard tooling and fixtures. So Joseph, that's a brief answer to your question.
Yeah, and then in terms of, we'll might get a little bit at this later, in DMLS, you're looking at parts that have like pretty high precision. And so that's historically what people have been using DMLS parts for, is smaller, really high precision metal parts.
Or larger, like some larger parts, but like they're generally very like complex in their geometries. They use their lattices. They're super custom. They leverage the fact that a powder printer can print with a bunch of interesting geometries. But with that, we wanted to get into kind of the lesser talked about, but I think really important thing to talk about DMLS, which is how much does it cost to actually run the machine. So the first thing is that when we talk about running machines, we generally talk about material. And that is the first cost of an SLM machine, but really not the only one, right?
Yeah, and so as we mentioned, there's all of these moving parts, not literal moving parts, but moving parts of the process of printing in metal. And so you have to have people who are carrying out those processes. So if you're changing material, for example, in a DMLS process, that's pretty involved because you have to wear a lot of PPE to actually interact with that metal powder. It has to be skilled labor that you're using to work with it. And so labor is a huge one. And then maintenance of the machine is also huge. It's like if you own a car, you can't just drive the car forever. You have to maintenance the car. And power is another big one. You're using really high powered laser and a bunch of different pieces of equipment. So power is gonna be another thing that you're paying for. But in terms of material, an interesting thing that many people don't know about DMLS processes is that you don't actually get 100% yield of the material, because basically you have this bed of metal powder that you're adding layer by layer, but you're only sintering parts of the powder, and the powder can't be 100% recycled.
It's pretty good, but not great.
Yeah, and so basically you're buying the powder by the kilogram, which is about $100 a kilogram for the powder for 17.4 stainless steel. But you don't have 100% yield of that powder. So, you're looking more between $150 to $200 a kilogram effectively for material.
Yeah, and as Nick said, I think it varies how good different machines are at recycling powder. Some are up in the 90% range in terms of powder recycled, but others are not. And as Nick said, basically you have this giant build plate, which is this build bounding volume, and you have to fill the entire thing with powder to actually make it work. So even if the part is a pretty small volume, say you're printing kind of a tall, thin part, you have to use a ton of powder in the actual process, and you might lose some of that powder. So that's a big thing. So the next thing associated with kind of SLM printing is the labor involved. And there's a lot of skilled labor in SLM printing because the machines usually take a person to operate, because like at least one person's time to operate. And it usually has to be pretty skilled labor, because the actual using of the machine, maintaining of the machine, operating this thing is a little bit more complex than, say, your typical 3D printer.
Yeah, and again, this person's going to be operating the printer. They'll have to be kicking off jobs on the wire EDM, in the heat treatment furnace. And so it's a kind of a wide range of skills that you have to be able to get part from design to actual part in hand.
Yep.
So I think that's a pretty holistic overview of the DMLS process. And then I think now we're going to transition to talking about the Markforged process, and then we can directly compare some costs.
Yeah, there's also a couple others, like just electricity costs and maintenance costs that come with that. And you can imagine with a more expensive machine like a DMLS machine, the parts in the machine are a bit more expensive as well. So some other things there, and we can get deeper into that if we want to. But I think we want to get to our printer and talk a little bit more about what goes into actually running one of ours. Yeah.
So back to startup investment. So our printer, if you've read our website, something that is talked about a lot with it is that it's that really low initial investment. And we'll get into the actual operational costs of it, which do exist as well. We're not going to pretend like it's free to run the machine. But in terms of startup investments, for that printer itself, it's a $99,500, so about $100,000 for the printer. But with our process, if you tuned in last week, you'll know that there is a debinding washing process, and then there's a sintering process that happens in a furnace. And so that wash and that sinter are both, you purchase both of those with the printer, and together those run around 25 or 30 grand total for those two.
For the Sinter one, the Sinter 2, which is coming out later this year, which is a larger furnace, will be a little bit more expensive. But yeah, the Sinter one is about $25K.
Yeah, so you're looking at, for just the hardware alone, it's about $130,000. And so you can directly compare that to DMLS, where it's about 5 times less expensive, maybe a little less expensive than that. But then, as we mentioned, you have installment that you have to do of the actual printer. So and the wash and the sinter. So there is a small facility upgrade that's nothing compared to a DMLS upgrade, but you need ventilation when you're dealing with the environment of the wash and sinter. So we have Optimum Scion, which is the solution that's used in the washing process, and then the atmosphere that's used in the sintering process, you also need ventilation for. So the ventilation is something that you'll have to add to the room that these machines are in.
Yep, and then you also need the sinter runs. The wash and the Metal X just are fine if you use 20 amp. They're kind of exclusive 20 amp circuits, so just give them their own breaker basically. The sinter is a little bit more powerful, as you can imagine. It heats up, so you need to do a little. It's like a 200 to 240 volt. I can't remember exactly how many amps off the top of my head circuit. So you do have to do a little bit of electrical work as well to get that running. And then, as Nick said, exhaust. And then also for the sinter uses gas. So you need to basically set up a gas panel on your wall. You need to basically figure out a place to hold basically pressurized gas tanks, and have generally good practice there is to have a cage for both unused and used ones as well. So there's some costs. I think we budgeted around 10 to 15K roughly to get started.
So if you look at machine costs, which is around 130,000, that plus installation plus exhaust that you need for the other 2 machines, you're looking at probably just under 200K.
Yeah, I think, we say like 160 to 200 depending on the thing. The other thing that we'd note is that with our printers, we basically ask our customers to purchase a success plan as well. And I think that's like, I don't know the exact numbers, I believe it's like 15K. The reason we do that is all maintenance on the printer is then basically covered by the success plan, unless you like physically take a hammer to the printer. I think basically any other breakage and any other material stuff goes down there. And that, as a result, allows the maintenance fee of the printer, which we'll talk about in terms of operation, to go to near zero, because all of it's being paid up front. And so we think this is a good value, but because of both ease of mind and the fact that you just don't have to worry about it. Those are both kind of key things in terms of operating printer and making sure it works.
Yeah, so some quick notes on those. So that's all the upfront costs for the Metal X process. Some quick notes on that. Upgrades that have to do with safety are very minimal. I mean, you have to add a gas panel to the room you're in, but that's a pretty standard process. But in terms of having an atmosphere controlled room, having to wear PPE and have safety training on running the machines is a lot lower. And in terms of extra machinery you have to buy, there are 3 units of hardware that you need to buy that come in a package, but you don't need a laser EDM. You don't need a heat treatment furnace, but I mean, a lot of the metals you print in on the Metal X, like H13 tool steel, for example, you would want to heat treat anyways, but it's not necessary to have a working part out of the printer, like with DMLS, where you need to stress relieve the part when it comes out.
Yep. And then also as we say, our parts are like relatively accurate. If you need precise finishes, we say something between near net shape and I don't think we've defined a specific tolerance spec. But then if you need to post-process your parts by milling, if you need to purchase a mill, I mean, you could, but I think that most people who are looking to get a machine like this probably already have machining capabilities in-house. So that'll work well with whatever you have. Same with DMLS, we don't like to budget that cost in. It's just worth noting that if you didn't have a mill, it would be worth getting one to kind of get the most out of some aspects of these parts.
Yeah, so that's all the startup costs of owning a Metal X. In terms of the operational investment, you actually see a lot lower costs in terms of operational investment as well. So materials, so if we're talking 17.4 pH stainless steel, which was the first metal material that we released, it's about $130 for a 1 kilogram spool.
Yep.
So it's actually about the same as DMLS powder in terms of the cost per weight that you're purchasing.
Yep.
And then you have labor. Obviously, you have to have someone to operate the printer, put the parts in the wash, put the parts in the sinter, and kick off all of those processes. And then depreciation of the hardware as well. And then maintenance of the machines. So as Daniel mentioned, maintenance is something that is largely covered in the success plan when you take that into account.
There are also a couple of consumables, like our print sheets are, I think, $2 to a couple dollars a print sheet.
Yeah.
And so that just adds a little bit to each print. They're recyclable and they're vacuumed down to the print bed. So that's a nice, easy process. We also, I think, nozzle replacements as well. I think they're included in the success plans as well.
Yeah,
so,
and then electricity as well is a process that, or is something you have to pay for with this process as well. You don't, it's not electricity free. And so yeah, so that's kind of the overview of it, and I think we can just dive deeper into looking at the actual cost analysis of the part.
And so I noticed there weren't too many questions. If anyone has a question about costs or about just generally the AM stuff, let us know, and we can address it. But with that, we wanted to just talk about this part, which is, I think you guys can see a little bit. It's a part we talk about pretty often. It's called an actuator housing. It's a part that basically goes on a hydraulic post-hole driver. You can see as it fits in my hand, it's about 2 and 3 inches long and 1.5 inches wide, 1.5 inches tall. And just talk about the cost of printing this via our method versus DMLS. And so, Nick, do you want to kind of get into the scoping of it?
Yeah, so we basically use this tool that we use to calculate the cost difference between using the DMLS process and using the Markforged process. And this takes into account everything that we've just laid out for you, including labor of setup time for the printer, including the depreciation of the machines, and we'll give it to you with and without depreciation, so you can kind of see how those calculations actually compare. And so just to note, this actually gets kind of complicated the deeper you go into it. And the reason is we're going to look at cost per part, but cost per part changes dramatically based on what kind of batch process you're using. So, and we're going to assume here that you're printing 6 of these on a DMLS machine, and also printing 6 of them in the printer, and then running 6 at a time in the wash, and then 6 in a batch in the sinter. And so to try to give that one-to-one comparison.
Yep. And so yeah, these batch considerations, they actually line up pretty well. DMLS as a process is a bit faster than our printers, but our printers can be parallelized because they're a lot cheaper. And the wash throughput and the sinter throughput are higher than the printer throughput. So that's actually an interesting wrinkle as well with how our stuff operates. So first let's go through our process, I guess.
Yeah, so in our process, this actuator housing weighs probably a little less than half a pound. And so in terms of materials cost, it's gonna be about $37 worth of filament that's to print this part. And so if you were to print a build of 6 of them, it would take a few days to do that for 6 of these parts. And then you would have to wash all of them for about 2 days based on the thickness of this part, and then the sintering profile is about 1 day long. And so with a lead time of a few days, and you get 6 of these parts out, that's going to be a little bit longer of a lead time than the DMLS process. But when you calculate the labor involved in moving the parts between each one, the electricity for each of the 3 machines, and the materials cost plus depreciation of the machine, you get a cost per part of about $125 per part.
Yep. And then just a couple bit of more details on the cost there. So this takes into account the wash fluid and the occasional need to replace that. This also takes into account sintering is basically, the sintering process uses like a certain amount of gas per sinter. And so we take into account that batch cost per that, and then distribute the cost of that sintering across the cost of each part. So the sintering run is about $80 to $100 a run, but you can fit a bunch of parts in it at once. So if you're doing batch processing, and you can kind of make that more efficient. Also worth noting, the sinter doesn't need to know what parts are in it. They just need to be the same material. So let's say I was printed 6 parts, but they were like they looked like this, they looked similar to this, or they were same material, but they were a little bit different. So long as they fit in the sintering oven, that you can sinter them together. So it's not like you need to print 6 of the same parts. It's just you need to print 6 of any part. And then with the speed, as Nick said, the washing a part like this is like basically a couple days. Sintering is 1 day for basically every process. The printing could decrease in time. So if you had 2 printers or 3 printers, that throughput for the 6 parts might be 4 days instead of 6. So and that's basically because you can cut that print time down 3 days, 3 days or so to a day.
Yeah.
And so when you're thinking about these processes, if you were to make 1 part and then wash 1 part and sinter 1 part, it would be a different cost. Than making a few parts and then doing the batch process.
Yep, exactly. And so, so as I mentioned, that $120, $125 for this part includes depreciation of the machine. So if you take that away and we're basing that you're owning the machine for somewhere between 5 and 10 years. So if you take away that cost, that's about $60 of appreciation. So the actual cost of this part, if you just take the upfront investment as an upfront investment, is closer to $60 for each part.
Yeah. So that's equivalent to, like, if you basically divide the throughput of the machine divided by the assumed lifetime of the machine, that's like, it comes out to like $50 a part. And we have a per hour operating fee, basically assuming that. and assuming some percentage of uptime, and we can share that as well. Someone just asked if we can share the cost breakdown as a slide or a Google Sheet. We're happy. We don't have the capabilities to share the screen during this presentation right now. But if you reach out to us via basically just drop your email or send basically reach out through our contact us, we're happy to send you all of this kind of detailing. We have this is all coming from basically a pretty detailed costing sheet that we kind of evaluate all of our printing processes against to say, okay, what's the actual cost of our material beyond estimations? And so we have the ability to do that, and we can help you out with that if you're interested.
All right, so we might as well take a quick pause to answer a couple of these questions. Question from Derek: can you build a solid part in your printer, or do you need infill after so many external solid layers? So good question. It depends on this. Right now, it depends on the size of the part. So for smaller parts, you do have the option to print with solid infill. As parts get larger, basically as parts get about this size or larger, it does print with an infill. And so the wall thickness of each part is around like 1.5 millimeters or so.
Yeah.
And so that's your kind of machinable layer before you get into that infill. And as we continue to improve on our printing process, we're gonna hopefully have the ability to increase that wall thickness in those areas that you really want to be able to machine for high precision.
Yep. In terms of our process right now, we have kind of two modes. One is the kind of main mode, and then one we just kind of shipped out in beta. The main mode is, I think, about 125 micron layer height, and that has the infill. And then we just shipped out a 50 micron solid infill for small parts. That being said, I think we're looking to expand the capabilities of the solid printing up in larger sizes. The constraint on the size of the part is basically the wash time. So the wash time, I think we talked about this last week, but the wash time of the part is basically exponentially related to basically the maximum distance from the surface of the part. So if you have basically a big flat plate, that doesn't take long to wash because everything is close to the surface. If you have a cube, it takes a really long time to wash if it's a solid part because it's got basically the solution has to permeate all the way in. For a part like this part actually doesn't have too many thick surfaces. So like in our washing regime, it is possible for this part to be printed. It's like technically possible. Right now, we don't have it as a formal feature, but I think that's something we'll get to in time. And yes, yeah, so there are two questions about that. As we said, Dmls or SLM can print solid parts. Is Markforged able to print solid parts? Yeah. So the answer is yes. We already can a little bit right now, and we're kind of expanding that capability as we get better. But our number one goal is reliability.
Yep. We have large material spool for the Metal X, more than 1 kilogram. So I don't know necessarily what the product path is for that, but if you have a part that weighs more than 1 kilogram, the spool can be interchanged when it runs out mid-print.
Yeah, so it'll pause itself automatically, and you can pretty easily change it. It doesn't print, so it prints at speed. It's not like you need to change one every 2 hours. It's like you can tell and it'll run out, and it's pretty easy process.
Yeah, you can print for quite a few days without running out of material.
Derek asked if the cost would increase as well. So the material cost would increase a little bit, but not massively. So it depends. So if you're printing a big cube, your material cost might go up by like 20-30%. But if you're printing like a part like this, it probably would go up less because a lot of the weight of this part, there's not too much infill in this part because it has a hollow cavity here. I'm not sure if you can see that, but it has a bunch of hollow cavities, and so there's actually the kind of the wall to infill ratio on this part is pretty high, and so that means that the cost wouldn't go up, but it would go up at all.
We have one question from Luke. A recommended CNC machine to accommodate a Metal X for an R&D type application that is capable of machining all the materials the Metal X will print in. That's a good question. I don't specifically know the answer to that. We will be able to print in titanium and Inconel here pretty soon, and I have never machined either of those materials, so I cannot give you a good answer for that.
Generally, I think it's like if you have a 3 or 4 axis CNC machine, it really depends on what you're trying to machine. If you're trying to just face off features, you might need like one type of machine. Like I know that we've machined parts. We've basically face machined and bored out holes in just like a $20,000 Tormach CNC machine many times. But if you wanted to get a little bit more complex, do surface milling, you might need like a 4 or 5 axis Haas mill or something a bit more expensive. So it depends. If you're interested, if you're kind of getting interested in that, we can definitely chat with you about that. Feel free to get in contact with us. But yeah, so as we mentioned, so the Metal X cost is about $120 per part if you include machine depreciation. and about 60, 65 if you don't, or 60
Mm-hmm.
65 if you don't. So what's the DMLS cost?
So if we look at the DMLS cost, let me pull my sheet back up. So the DMLS cost, as I mentioned, for the materials, the material cost is pretty similar, but again, you're not getting 100% actual usage out of your powder materials. So the materials costs end up being a little bit higher for the DMLS process. And then what you're looking at is higher machine depreciation, obviously, because it's a higher upfront cost, but we'll look at it without the depreciation as well. And then in terms of maintenance, electricity, and labor, that's going to be a cost that's nearly as high as the cost of the materials that you're using to print, which is one big difference between the DMLS process and the Markforged process, because you're putting in a couple hours of labor of setup and takedown time for each print.
Yep. So you have to do a lot of work to properly load everything, and then a lot of the work happens post print. So after you finish a print, basically at the end of our prints, the part just kind of sits on the bed like a plastic thing. The end of a DMLS print will basically just look like a tub of powder. So the first thing you have to do is depowder everything. So that means basically vacuum up all the powder, and that's how you recycle it. And that'll leave you with your part, which is generally this big metal build plate with, as we said, parts literally welded to it. So then the next thing you do is you have to get basically a skilled wire EDM operator or a very, very skilled bandsaw operator with a giant bandsaw. But we generally, wire EDM is recommended here to basically cut those parts off very precisely from that metal build plate. And then to use the metal build plate again, you need to then face it with a mill to make sure that metal build plate is flat again. And then after that, you need to, if there's supports in the part, which are very common for DMLS, you need to basically grind those supports off individually. And then you need to surface machine it. And so there's basically just a ton of process to get those very pretty parts you'll see off DMLS machines.
Yep. So with all of those costs included, what you see for your final part cost for a DMLS part of this exact part. Also, again, side note, we assumed that you're going to print this in a batch of 6, just like we did with the Metal X process. Yep. And the DMLS cost per part, including machine depreciation, is around $280.
Yep. And it would be nothing if you print with one here. One thing you'd have to do is you'd have to then, if you printed 6 different builds of this, you'd have to wire EDM it off 6 different times. So that would cause the cost to go up as well. So the batch process does benefit DMLS as well, although maybe a little bit less than our process, because the sinter is a distinctly batch process.
Yeah. So I think it's a little it's kind of double dipping to say DMLS is this much more expensive upfront, and also it's way more expensive operationally because if you include depreciation of the machine, you're really double dipping on that cost. So if you compare them head to head without depreciation, the DMLS cost per part is closer to like $180, $190 per part, which if we look at including machine depreciation of each is 2 to 3 times more expensive per part for this specific part compared across the machines.
Yeah, so you expect 60 for a 60 on our printer and 180 on a DMLS machine, no depreciation.
And so one thing to bring up, and this kind of answers one question that was asked, is what's the speed comparison between the machines? And Daniel alluded to this earlier. And in a batch process, a DMLS process will print this part quicker. You will get the part in a shorter lead time. Mm-hmm. And so that's the honest answer. But my response to that would be, if the upfront cost of a Metal X is about 5 times less than the upfront cost of a DMLS machine, one thing that some of our customers do is they put the Metal X in parallel with more Metal X's. So when you buy a Metal X and you buy the wash and you buy the sinter, you can have multiple machines for each wash and sinter. So you might buy a package and then you just buy another additional Metal X without having to pay for a wash and sinter again. Yep. And so if you have 3 Metal X's running, that allows you to triple basically the efficiency of printing these parts. And so then that decreases your lead time drastically.
Yep. And the other thing is they're faster, but they just take the amount of labor to keep them running faster is huge. So you imagine the process here is a little bit slower and requires a lot less labor. If you're running a tighter cycle on, say, a DMLS part and trying to produce, you really need to put in hours and hours a day of skilled labor to make that work. And that, like, if you're trying to produce anything with that type of process, it is a significant money, time, and labor investment. And so that's the truth of it. Someone just asked a really good question, which is, are material properties well enough defined to enable accurate simulation? So there's 2 answers to this question. I'll take the first one, which is the material properties are pretty well defined for all of our materials that are shipping. So right now we're shipping 17.4 pH and stainless steel and H13 tool steel. For those, we have data sheets that have pretty detailed data on both the material properties immediately out of the sintering oven and the material properties that are basically post heat treatment with a variety of heat treatments for both 17.4 and then the one main heat treatment for H13. So that's pretty well defined. If you have interest in that, please reach out. We'll send you the data sheets and talk about that stuff. The other half of it, which I'll let Nick talk about, is the actual simulation part, which is really exciting because we just started, well, a couple weeks ago, we just announced a collaboration with NX, which is Siemens software.
Yeah, so for years, so we get this question all the time about simulation of 3D printed parts. And for years, this has been something that people really want because it's part of the normal workflow of an engineer, but it's very challenging to do with 3D printing for a few different reasons. Specifically for metal printing, the Metal X process, you're dealing with parts that have infill. And so while there is isotropic strength throughout the part between layer lines, unlike a lot of printing processes in metal printing, the infill of the Metal X process makes it a little difficult to actually simulate because you have a certain lattice pattern that's inside the part.
Yep.
And with 3D printing in general, it's a hard thing to do. But as Daniel mentioned, we just announced our partnership with Siemens. NX is an integrated CAD/CAM software that is used across different Siemens companies. And we're working directly with them for the ability to integrate our software with theirs so that you can run simulations and run that FEA analysis on your parts and be able to slice your parts seamlessly through that process.
Yep, and so the idea is that it introduces feedback between the slicing software, which is basically taking your assumed to be solid part and making it not solid, and then that new not solid part would be kind of re-exported to Siemens, the Siemens software, or basically all done within the Siemens software. So then you can simulate the actual geometry of the printed part. So with solid parts, this is simpler. And so as we get better at printing solid parts, the simulation will become easier. For parts that have this open cell infill, this is a huge win because now the biggest thing or problem with open cell infill is that it's anisotropic and hard to simulate. And now that's like kind of not only readily doable, but in a closed feedback loop with the CAD system.
Yeah, so we're really bridging that gap between slicing softwares and the innovations that are happening there and CAD/CAM softwares where they have really powerful simulation tools. And being able to merge those together is going to be really exciting to see industrial 3D printing take off even more in these larger enterprise companies.
Yep. Does anyone have any more questions on the live stream? We've gone through most of the stuff we're planning to talk about today. If you have questions about the Metal X, feel happy to answer them about the general costs of stuff, about what this part is and why it's beneficial to print. Like that kind of stuff we're happy to talk about.
All right, so it looks like we've got another question, and you can keep them coming in. We'll leave a few minutes to answer questions here at the end. Thinking about some product to response to scale demands like desktop metal.
Interesting.
I
assume they're talking about binder jetting. Right?
So I think this question is kind of about like production system in terms of being able to have massive throughput for mass production. So one thing I will say to this is we're constantly thinking about how we can improve our printers. So we just talked about putting Metal X's in parallel to increase throughput. And so in terms of mass production systems, metal printing definitely is not there right now, but we're all constantly exploring our technology to really improve the throughput of machines to be able to save you money and make you print parts that you could not print before.
Yeah, and in terms of right now, the thing that's kind of been promised as kind of a mass production by a few different companies is binder jetting. So that's like a process basically, which is also a powder-based metal process. So again, pretty difficult and expensive to implement for a variety of reasons. But basically the core of that is that instead of using a laser to bind the parts together, you use basically just a polymer binder, and then afterwards you sinter the part. And so it's lower energy, and theoretically that printing process is faster than laser printing. So really interesting. I think we've talked about it a few times on the show before. Definitely talked about it in the first episode, which is like the 2019 trends episode. But feel free to watch that if you want to learn more about that kind of process. It is metal production is definitely buzzy. Right now, we're just working on the metal system, our Metal X system, and making it as the best system we possibly can. Someone asked, can you compare the accuracies? So yeah, we can. I'll talk about Dmls accuracy super quick. So Dmls accuracies basically correspond to three things. So one is layer height, and so that's basically across any printer. Your layer height depends on that'll determine kind of your resolution. So in that respect, if your layer height is one height, that's basically the minimum resolution you can expect from a feature in the z-axis. But then more importantly on DMLS, the laser diameter is really one of the big things that corresponds to the actual accuracy. When you see companies like, so a company like EOS is is an accurate machine, but their laser diameter is a lot larger than 3D Systems lasers, which are 3D Systems are known generally for smaller diameter, more accurate lasers. And so it really depends on that. And then you go on the other end and like you go to like RCAM, who does electron beam manufacturing, not even like laser stuff, and they're the least accurate. So it really depends on how precise your laser is and how fast you're moving. And the last factor on DMLS is warping. So because it's a melting by parts process, the accuracy part can be totally undermined if your part actually warps. So the overall accuracy, you can get some really accurate parts out of DMLS. I don't know their quoted accuracies, but I would presume like in the 5 thou range. And I've also seen some insanely accurate or imprecise small features. Yeah. The Metal X is a bit different because it's a filament-based printer though. Yeah, and so the Metal X, as we mentioned, we say near net shape. And so it's because, as we say, very often it's geometry and size dependent for the part. And a lot of that is with the sintering process and the printing process together, it introduces a little bit of uncertainty there. But we have seen accuracies within a little above 5 thou, I would say, if I had to give you a number. But again, it's something that changes depending on the geometry of the part. Geometry dependent is the most commonly used line in 3D printing. Yeah, exactly. Everyone uses it. It's great. Dylan asked one more question, which was just what is the total running cost of each of the machines again? We'll make sure to put this in the comments for the video, just so you can, if you come back to it, you can check it out. So the cost per part is $60 for this VR process, $180-ish for a DMLS process. And then with depreciation, that goes to $120 for our process and $290 for their process. In terms of like per hour usage costs, we didn't talk about that directly, but there are some basic guesses for numbers there. But that's in terms of comparing it part by part, which is kind of a good mode, kind of the most robust way to do it. That's the comparison. Yeah. All right. So one last question, and then I think we'll sign off. Is biocompatible material available for stainless steel and titanium? So right now we are not certified. Our materials aren't certified to be biocompatible. That doesn't mean they won't be in the future, but that's a certification that we have not gone through for our parts. Yeah. Also worth noting, 316L, which is a material that we're in development and relatively close to launching in the near future, is more of a biocompatible material than 17.4 is a stainless steel. Titanium is a bit further away as a material. 17.4 is more of a really high hardness, high strength steel. 316L is the type of thing you'd see used for like forks or knives or like kitchen appliances. So it's a bit of a difference there, and that's something that's coming down the pipe pretty soon. No certifications yet though. Great. So I think that wraps it up for us. Thank you for joining us on this Friday, and if you enjoyed it, you should tune in next week as well. We're going to be talking more about metal stuff next week, as we have been the past couple of weeks. Yep. And yeah, thanks for joining. Yeah, and happy printing.